those calculators in your other classes. Make sure we're missing number 1 and number 30. So, yeah, kind of weird, right? Well, and you know, you'd think that if their calculator was missing, that they'd tell me. So I could be like, okay, I'm going to ask the person who had it before you, but they don't, and so then I don't know. Anyway, for real. All right. We are starting trigonometry, which I'm super excited for. I absolutely love trig. It came first. Geometry and trigonometry all happened way before algebra. We're talking hundreds and hundreds of years before algebra. So it's all really cool how it came to be, and I really love it, and the more I teach it, the more I love it. So I do need a calculator. All right, so you should have a calculator. So today we're talking about degrees and radians, and you're pretty familiar with degrees, but we want to make sure that we're drawing things properly. I am a stickler for drawing pictures because when you draw a picture, it just makes things make sense a lot better, okay? And that's the nice thing about trigonometry is there's always a picture. Trigonometry is the study of triangles, but it actually turns out to be the study of circles, all right, which is kind of interesting. So we have a picture right here of an angle in standard position. She calls it standard form. I call it standard position. An angle on the coordinate plane is in standard position when the vertex is on the origin. So we have the vertex of the angle. That's the point where the angle swivels open from. It's that swinging point. So that vertex is on the origin. And we have this initial side, that's called the initial side. It's placed on the positive x-axis. So the ray on the x-axis is called the initial side of the angle. And then so that initial side stays on that x-axis, the positive x-axis, and then the angle sweeps open, okay? And as that angle sweeps open, this other ray right here, the other ray is called the terminal side of the angle. So we have an initial side, and we have the terminal side of our angle. Would you estimate for me how big do you think this angle is approximately? 135. Good. What did you say, Brody? Okay. So 135. What if it was, here's my angle. What if I had my angle right here, my initial side is on the positive x-axis, and I sweep it open, and it's right here, my terminal side is going straight up. How big is that angle? 90 degrees. Okay, very good. So this is a 90-degree angle, and if I open it all the way up, and now it's a straight angle, how many degrees is it? 180. If I open it up and I continue around like this, and I open it up and I land down here on the negative y-axis, how many degrees is it? 270. And if I do a full rotation, how many degrees is it? 360. Okay, so when we have angles opening counterclockwise rotations result in positive angle measures. But we also have things, we could open angles with clockwise rotations. They would result in negative angle measures. And so we're going to get good at drawing positive and negative angle measures. The most common unit of measure for angles is the degree. And it's important that when we use degrees, you'll notice that there's always a degree symbol. That's telling you we're using degrees. Now, it's the most common unit of measure, but it's not the best unit of measure. It's actually really highly inaccurate. And it's not great. You'll see why in a minute. So a degree, one single degree, is equivalent to how much of a full rotation? Yeah, 1 out of 360 degrees of a full rotation. It's 1/360th of a rotation, which is great and all, but we want to sketch some angles in standard position given the measure. So 65 degrees in standard position. I'm going to start with my angle, my initial side here on the positive x-axis, and I'm going to sweep open my angle here and draw my terminal side. So right here is about 65 probably degrees. Did you draw your angle in standard position? Okay. So 320 degrees. Where's that going to land? Fourth quadrant, yeah. So this is what's interesting here. This we know is quadrant 1, right? And we keep sweeping open our angle. We might end in quadrant 2 or 3. And this 320 is going to end in quadrant 4. Ladies and gentlemen, this is why the quadrants are numbered this way. Did you know that? Did you always wonder why they didn't just number them 1, 2, 3, and 4? Left to right, top to bottom, like normal reading? This is why. Because trigonometry came first, and this is how we sweep open angles, okay? All right, so I have my initial side here on the positive x-axis, 320, 90, 180, 270, 300, 320. Okay, maybe it's about right there. All right, so there is our angle opening. We use this little rotation arrow to describe how the rotation is occurring. Okay, so that little rotation arrow is pretty important. But somewhere in there, what about 415 degrees? Yeah, it goes more than a full rotation, and that's fine. It can keep going. Let's see, how much more than a full rotation? How'd you get 55 degrees? Oh, you subtracted 360. That's so smart. Yeah, 55 degrees. That seems right. All right. So we're going to do one full rotation. So I have my little swirl working, and then an extra 55 or so degrees, and we're going to end about right there. So there's our 415 degree angle there. Okay. What about negative 140? It goes the opposite way. We still begin on the positive x-axis, but our rotation is now downward. And let's see, that's 90 and 140 would be, I don't know, about right there. So this is terminating in quadrant 3. So terminal side in quadrant 3. What about negative 15 degrees? Just a little bit. It's just a little baby. Yeah, negative 15 degrees. Okay. Just a little baby. All right, negative 210, where's that going to terminate? In quadrant 2, good. We're going to go negative 90, negative 180, and then a little bit more, so negative 210 degrees there, okay? All right, you feel good with that? Yeah. Pretty easy. So yes, our rotation can end up being more than just 360 degrees. That's why the X Games, you can do like a 1020 or whatever, you know, you can, 334.20 or something like crazy like that, right? How many times can you turn around? Okay. So it turns out that degrees, while they're the most common, they're not very good. So we've got to think about people were using trigonometry to sail across the sea, okay? Now you imagine you're traveling from, I don't know, South America somewhere and headed up to Canada, all right? Now you head due north. You're traveling quite far, right? Now imagine you're off 1 degree, but you've traveled really far, right? You're off 1 degree and you travel really, really far. how far away from where you intended to be are you going to be? Really far off, right? And that's the problem with degrees. It turns out that 1/360th of a degree is not accurate enough, okay? And so what we have, and the best unit to use, is a radian. Will you look at that word radian? It looks it sounds very much like another word. Radius, right? Okay, ladies and gentlemen, congratulations. A radian is simply a radius, okay? That's all it is. It is the length of a radius. So what we end up doing is we take our angle. So here we have a little angle inside a little circle here. And all it is saying, hey, my radius is this long. That is one radius. The length from the center of the circle to my edge of my circle is one radius. What I'm going to do is I'm going to take that radius, cut it out, and I'm going to use it to wrap around my circle. Okay? So that radius I'm cutting out right here, and then I'm going to lay it on the edge of my circle, and that now has been transformed into a radian. Okay? It is the measure of an angle that is swept out equal to the length of one radius. So you sweep out the length of one radius, and that gives you an angle measure of 1 radian. So this angle, I would call it right now, it would be a measure of 1 radian. Now, what I can do is I can take that same radius, and I can add it on to the edge here. So I'm going to sweep out another radius length. So here's another radius length. And now I get this angle right here. That starts on my initial side, and it's now opening up this big. Well, how many radians is that angle? Yeah, it's 2 radians, because I swept out arcs that were 2 radiuses long. Okay? Then I could go again. I can sweep out another radius length. There we go, there's another radius. And now my angle starts here in standard position, and it sweeps out, and I'm about right here. So how many radians is my angle now? Now it's 3 radians. Good. How many radians do you think it takes to get all the way around? 6.28 is exactly right, yeah. So what we're doing here, we know what we're sweeping out is a piece of the circumference, all right, the circumference of the circle. 360 degrees is equal to, that whole rotation would be equal to a whole rotation of the circumference. The circumference we know from geometry. Circumference is 2 pi times r. Well, I don't need the r, that's to measure the radians. 360 degrees is going to equal that whole circle, which I can reduce and say, hey, I can divide both by 2, right? Pi radian. I meant to write instead of r, that's a radian. 2 pi radians is going to give us that whole rotation, 2 pi radians, and then we can divide each side by 2, and it turns out that pi radians gives us a full 180 degrees. This is a nice measurement for us. We can use that to help us convert between radians and degrees. And so we're going to use this 180 degrees equals pi radians. And that's going to help us convert, okay? William said it was 6.28. You're right. All the way around 2 times pi, 2 times 3.14 is 6.28. So we get about 6.28 radians to complete that rotation, which is kind of interesting. Will you draw for me? I'm going to set up a little coordinate plane here, and I'm going to put on there a little circle. All right. Will you draw what you think might be an angle in standard position that is 4 radians? Draw an angle in standard position that would be 4 radians. What quadrant does it end in? Yeah, third quadrant. Good. So we got like 1 radian, we got about 2 radians, we got 3 radians, and 4, be about there. So right about here is your 4 radians for your angle measure, which is kind of interesting. Where would 5 end? One more quadrant, yeah, and 4th quadrant. Good, good, good. Okay. Great. Turn the page. So we're going to use this little knowledge that 360 degrees is 2 pi radians, or more simply, 180 degrees is pi radians. So I'm going to do this a lot. I'm going to say, where's pi? And you're going to go, it's 180 degrees. Okay? So where's pi? Oh, it's 180 degrees. And that's going to help us. We want to convert each angle measure into radians. So right now, what is it in? Degrees. And how do you know that? Because it has a degree symbol. Yeah. All right. That's a trick to... Hello? Okay. Bye. Lucy, you're headed out. Let me give you the assignment here. There you go. Okay. Okay. So, big trick to trigonometry is knowing whether or not in your radians or degrees. All right. So, we know that, ladies and gentlemen, where's pi? 180. So, pi equals 180 degrees. This is our conversion factor. I have degrees. We're going to multiply by pi on top. I need to cancel out the degrees, so degrees goes on the bottom. So we have degrees on top, degrees on bottom. Those are going to cancel each other out. I'm going to multiply straight across. 60 pi over 180. 1/3. The zeros cross out, and 6 over 18 reduces to 1/3. Pi over 3 radians is how that works. Let's try another one. I have degrees. To cancel degrees, I'm going to put my 180 on the bottom so they cancel out. Pi goes on top. And I can multiply straight across 160 times pi over 180. The zeros are going to cross out, and what about 16 and 18? Yep, we can divide by 2, so we would get 8 pi on top and 9 on the bottom. So 8 pi over 9 radians. Okay, let's try just fractions. That's all this is. We're just going to do fractions all over the place in trigonometry. That's all it is. Negative 45 degrees. I want to put 180 degrees on the bottom. Pi radians on top. Going to multiply straight across. Negative 45 pi over 180. How many 45s are in 180? Yeah, 1/4. 4. Yeah, so it goes 45, 90, 135, 180. So let's see, that's going to be negative 1 pi over 4. If you need to, you can use your calculator because you do have numbers here. Negative 45 divided by 180. Crazy math bracket, you get 1/4. Okay, so you can use your calculator if you need to. All right. So then, how do we convert each angle to degrees? Yeah, we sort of do the opposite. We're going to use the same conversion factor. Where's pi? 180. All right. Okay. So now, though, right now, are we in degrees or are we in radians? How do you know you're in radians? No. No. No degree symbol. That's how you know. Okay? Don't tell me there's pi. That means it's in radians. That ain't right. Pi is a number. Okay? It's coincidental in this case. The reason we're radians is because there's no degree symbol. That's the reason. All right? So I'm in radians, so I want degrees, so I'm going to put degrees on top, pi radians on the bottom. All right, what happens to the pi's? They do cancel out. And let's see, 5 times, I don't know what 5 times 180 is. 5 times 180 is 900. So 900 degrees over 18. 900 divided by 18. Oh, 50. Look at that. It was nice. So this is now 50 degrees. Okay. Again, 11 pi over 9. Is it in degrees or radians? Radians. How do you know? No degree symbol. Thank you very much. Thank you very much. If I've done anything, that is the one answer I need you to really understand. All right. So we want degrees, so I'm putting degrees on top and pi radians on the bottom. What happens with the pi's? They cancel out, and also, hey, 9 goes into 18 2 times. So that becomes a 20. What's 11 times 20? 2120? 220. You got it now? Yeah? Sometimes we're quick sometimes. All right, so yes, we get 220 degrees. All right, cool. And it works just the same with negatives. Do we need to do any more of those? No? Okay, turn the page. So, because degrees are so inaccurate, they decided they needed to subdivide them so they could be more accurate, so that they didn't wind up 500 miles off course in their travels in their boats, right? And so they subdivided degrees into minutes and seconds. So some angles have decimal degrees. For example, 26.5 degrees. So this would be 26 degrees and a half of a degree. All right, so sometimes we use decimal degrees. But angles with decimals can be expressed using degree, minute, second form, or DMS for short. So degrees, minutes, and second form, in which the degrees are subdivided into minutes and seconds. So they're going to take 1 degree and subdivide that 1 degree, and how many pieces using? 60. We're using minutes and seconds, so that's a big clue that we're using 60s. So 1 degree is equal to 60 minutes. Now, so you imagine I've got 1 degree in my angle, right? 1 little bitty degree. And I'm going to take that little bitty degree and subdivide it into 60 minutes, okay? Now I'm going to take one of those little baby minutes, all right? And that gets bigger, right, as you move out, right? That gets wider and wider and wider. And then we're going to take that 1 single minute and divide that, again, into 60 seconds. So you're subdividing your degrees, and you're subdividing each minute, and you're subdividing that further. So 1 whole degree has how many total seconds? 60 times 60, yes, 3,600 seconds. All right, the symbols for degrees, minutes, and seconds. So we know that degree, we use a little superscript circle. Minute, we use, it's a prime, technically, and double prime for the seconds. Yeah, sort of like inches of feet, but yeah, but it's really a prime and double prime in math. So we call it prime and double prime. All right. So for the following example, we want to convert 31.875 degrees to degree minute second form. And so you have to think about this. We have 31 whole degrees. And here we have 8/10 plus a little bit, all right, of a degree. So approximate, how many minutes do you suppose that is? Well, wait a minute. So if this was a 0.5, how many degrees would we have?
0.5.
We'd have 30 minutes, right? We'd have 30 minutes, all right? So we're going to have a little more than 30 minutes, right? Because this is like 870. Okay. Well, should we have more than 60 minutes? No. Yeah. Okay. So what we have here, right here, this is a fraction of a degree. All right, it is DREE. It is a fraction, a portion of the amount of degrees. So what I'm going to do is, if I were doing this, I have 0.875, a little less than 1 whole degree. Now, I need to convert that into how many minutes that is. So I'm going to multiply it by 60 minutes, because that's 60 minutes. I'm going to do prime. 60 minutes per 1 degree. All right, so we're going to take that 0.875, and then multiply it by 60. And so that's going to be 52.5. Now, what does that mean? 52.5. What is the 52? Yes, this is now 52 minutes. And what's this piece? Well, it's a fraction of 1 minute. Okay? It's 0.5 of a minute. All right? So I need to take that little fractional part. So the 0.5, that is a part of a minute. And I'm going to multiply it by 60 seconds, and that's going to give me, yeah, so 0.5 times 60 is 30 minutes, okay? So therefore, we have 31 whole degrees, we get 52 whole minutes, and then we get the 30 seconds on the leftover bit, okay? So, let's try one more here. Let's try number 1, I guess. All right, what is this 15? We got 15 whole degrees, so I'm going to take my little fractional portion, 0.48 degrees, and multiply it by 60 minutes. 0.48 times 60 is, 28.8 seconds. So what does that mean? I have 28 whole seconds. What do I do with my fractional bit? I did right. I wrote 28 minutes. Yeah, so now I have 0.8 minutes, and I'm going to, again, multiply that by 60 seconds. So 0.8 times 60 is 48 seconds. So that becomes 48 seconds. So 15 degrees, 28 minutes, and 48 seconds. Why don't you try number 3? All right, I got 89 degrees, 54 minutes, and 54 seconds. All right, good with that? Pretty easy. So we had to multiply by 60s to get degrees, minutes, and seconds. What if we gotta do the reverse? What if we're in, oh no. Oh, I goofed, you guys. Shoot. I goofed. So what if we have to go the other way? So let's say I got to go the other way. 73 degrees, 9 minutes, and 50 seconds. And we want to convert it to decimal degrees. You would do the division, but it's a little bit different. I already know I have 73 whole degrees, so I need to take my 9 minutes and I need to convert it into degree form. So I'm thinking I want degrees. I know that 1 degree has 60 minutes. So that's what I'm thinking when I do this. So yes, you do end up dividing. 9 divided by 60 is 0.15. So that is 0.15 of a degree. All right, but now this is 50 minutes. And again, I want 1 whole degree because I'm looking for full degrees here. How many minutes or how many seconds are in a degree? Yeah, 3,600 seconds are in 1 degree. So in this one, we have to actually divide by 3,600. So 50 divided by 3,600 gives me like 0.13. I guess it's about a 9. It's repeating. So 0.139. And again, now that's degrees because our seconds are canceling out there. And so this is a portion of a degree, so we just have to add those things together. So 73 degrees plus 0.15 degrees plus 0.139 degrees gives me, 73, let's see, 73 point, nope, 0.15 plus 0.139. Oh, 0.0139. I'm missing a 0. Holy moly. 0.0139, 0.1639 whole degrees. All right, does that make sense to you? Yes. Do you need any more of those, or is that good? I think that's okay. All right, give that a try. You might want to start there on the homework. All right. Yeah.